Okay, in this video we're going to primarily discuss distance and displacement. Distance and displacement, okay? And what the difference of those two are. Let's start off with distance, okay? Now, if I asked you right now to spend some time and write your definition of distance, you would say something like, it's how far away you go, or it's how far away something is. And that's true, but we're going to give you the physics definition of it, and it is a scalar. And you should remember what a scalar is from our last video. Remember, a scalar is a numerical value, but it doesn't have direction. It's a scalar quantity describing how much ground, and I'm going to put ground in quotes because it doesn't necessarily have to be ground. It could be, you know, how far an airplane has traveled. How much ground an object has covered. How much ground an object has covered. That is the definition of distance. Displacement is a little bit different, and displacement's a little harder to understand. Displacement is the vector quantity. So remember, vector has a numerical value with direction. It's a vector quantity describing how out of place the object is. So, vector quantity describing how out of place an object is. Okay, so let's go ahead and let's spend some time and let's just draw a diagram here, and let's consider I want you to consider the following box. Now, just give me a moment here to draw this box. Okay, and let's pretend that somebody's actually walking around in this box. They're walking in specific directions, and this is the way they're walking, the way the arrows are pointing, okay? And I'm going to go ahead and put some measurements on here. Let's say that they start over here where the red dot is, okay? And they walk 4 meters this direction, 2 meters that direction, then 4 meters back that direction, followed by 2 more meters this way, okay? And we are in a north, west, east, south, like that, okay? And they started at the red dot. So if we're considering this, they're walking 4 meters to the east, that's the way the arrow's pointing, then they're walking 2 meters south, 4 meters west, 2 meters north. Let's calculate the total distance, okay? So the total distance is the total distance that the person or object actually moved, okay? Well, I'm sure you can all look at this and go, well, that's easy. They started here, they ended there. 4 plus 2 plus 4 plus 2, that's 12 meters. And that's correct. The total distance traveled is 12 meters. But what is the displacement? The displacement, remember, is how out of order is the object. Okay? How much has it changed? Well, in this scenario, it's changed 0 meters. Okay? 0 meters, no direction as well. It has no displacement. And here's why. The 4 meters to the east, okay, is canceled by the 4 meters to the west because they're in opposite directions. And the same thing, the 2 meters south is canceled by the 2 meters north. Okay, so in this scenario, the total displacement is 0, but the total distance is 12 meters. All right, let's go ahead and let's do another practice here. I'm going to clear this screen, and I'm going to paste this down here. I'll make this a little bit smaller so you can see it. Okay, so let's take a look at this cross-country skier, okay? And this is the position where they're starting right here at A, and then they're going to B, and then they're going to C, and then they're going to D. And overall time in this case is 3 minutes. Okay? Not that time really is playing much of a factor yet, but it will. What is the total distance and displacement of this cross-country skier after 10 minutes? Go ahead and spend just a couple minutes doing that. Okay, so let's run over this problem together. As the cross-country skier goes from A to B, they have traveled 40 meters plus 100 meters plus 40 meters. So we got the 40 plus 100 plus 40. So from A to B, that's 180 meters. Okay? Okay, so to continue this, we have gone from A to B, and that is 180 meters. Now we're going the cross-country skier is now going from B, position B, to position C. That's another 40 meters here, plus another 100 meters here. So from B to C, that's 100 meters plus 40 meters, so another 140 meters. Okay? Now the cross-country skier is going to go from position C to position D. C to D is only 100 meters. Okay? And the cross-country skier finishes right here at position D. Now if you add all these up to get the total distance, okay, you're going to get 180 plus 140 plus 100 equals 420 meters. Now, how about the displacement? Okay, well the displacement is just the change from the original position. So here's the original position, way down here. Here's the final position. What is the total displacement? 140 meters. Now, displacement is a vector, so it has to have a direction, and it's 140 meters rightward. It's towards the right. And that is an example of how to calculate total distance and displacement. All right, let's continue our talk about calculating total distance and displacement. Let's consider this picture here. This is a coach who is pacing themselves back and forth up and down the sidelines. And you can see that the coach will start at position A, go to position B, then to C, and then to D. So I'll go ahead and draw some arrows here so you can see that. So they'll go from A all the way over to B, Okay, and then from B, and that takes 3 minutes, and then from B they'll go to C, and from B to C that takes 3 more minutes, and then from C they'll go to D, and from C to D that's 4 minutes. Okay, so the overall time of doing that pacing is 10 minutes of pacing. Okay, that the coach is pacing up and down the sidelines. So what I'd like you to do is calculate the total distance that the coach paced up and down the sidelines. Then I'd also like you to calculate the displacement. Remember, the displacement is how much the object has changed from the original position. So spend some time, a couple minutes, calculating both of those. Alright, let's go ahead and spend some time calculating this together. So we're going to start with the total distance first. Okay, so let's calculate that. I'm going to switch my pen colors to blue. Total distance. So we have from A right here all the way to B over here. That's 3 minutes. Now let's go ahead and spend some time just looking at this. We're going from 50 yards down to 15 yards. Okay, so that is a distance of from A to B is 35 yards. Okay, now we're going to calculate from B to C. Okay, B to C, we're going from the 15 yard all the way up to the 35 yard. That is 20 yards. Okay, and finally from C to D. Okay, we're going from the C marking, which is the 35-yard line, okay, all the way to the D, which is down here, and this looks like it's -5 down here. Okay, so we're going from 35 down to the -5, which is 40 yards. Okay, and if we just spend a second here and we add these all up, you'll get 95 yards. Okay, so the coach has actually paced back and forth a grand total of 95 yards for the total distance. Okay, now the displacement, on the other hand, is from A to D, from the initial to the final. So here is the initial. Okay, and here is the final. Initial to final. Okay, going from the 50-yard marker all the way down to the -5. 50 to -5. That's a grand total of 55 yards. So as you can see here, total distance and displacement sometimes may be the same, but also can be different. Alright, let's go ahead and continue from this point, from this scenario. So here we've calculated the coach's displacement and total distance based on using a picture. Okay, now let's go ahead and let's say you're not given a picture of how far they go, you're just given velocities. And I'm going to show you how to mathematically be able to calculate displacement. So for displacement, you don't necessarily have to have a picture either. You can do this with a formula, and x equals are 1/2 times velocity okay, our current velocity plus our initial velocity. Okay, times time. So we'll rewrite this here. I'll put time here, and we'll go displacement, which is x, is 0.5, and I'm switching to using a decimal here because I prefer decimals over fractions, but 1/2 and 0.5 are the same number. Okay, times velocity plus the initial velocity, which we'll do as v sub 0, times time. Okay? Now, it is very, very extremely important that you remember your order of operations. Please excuse my dear Aunt Sally. Parentheses, exponents, multiplication, division, addition, subtraction. Okay, in that order. So we need to do everything in the parentheses first. So you're always going to add your velocity, which is probably your final velocity, plus your initial velocity. Then you're going to multiply that by 0.5 and multiply that by time. Okay? So let's go ahead and let's calculate some displacement. Let's go ahead and pretend a car is driving down the road, and their initial, let's just call it final velocity. Their velocity at the very end is, let's say, 35 meters per second. Okay, but their initial velocity was 0, so because they were stopped at a stop sign, let's say. So their initial velocity is 0 meters per second. Okay, and let's say they drive or down the road. Let me erase that. I can make that a little cleaner for you. They're driving down the road. Well, let's say 15 minutes. Okay? They're driving down the road for 15 minutes. And I want you to tell me what their displacement is. Okay? What is the displacement? Now, I'm not going to give you the answer yet or work through this with you. I want you to try to do this on your own. But I am going to highlight something in this problem. So now you're going to take these numbers and you're going to plug them into the formula. Yes, but I want you to notice right here, velocities are measured in meters per second. Okay? Our unit of time is seconds. Over here, we have minutes. So pay close attention to that. Go ahead and spend a couple minutes working through that.